Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for a new session and an interesting session in inorganic chemistry. Yes, we are starting with metallurgy today. Let me explain the first step of metallurgy, that is the different methods of concentration of force. Okay. So the elements that are very less reactive or not reactive will occur in free state. So for example, gold, silver, and then nitrogen, oxygen, platinum, helium, neon, etc. They are found to be not reactive, so they will be existing as in free state. Okay, whereas other elements like some elements are a little reactive and they occur in the form of its compounds, which is in the combined state. Okay, that's for example sodium, potassium, calcium, fluoride, and chloride. Okay, and elements with moderate reactivity occur in free as well as combined state, that is copper, iron, sulfur, etc. Okay, so before going into the topic, that is the concentration of ores, let us see what are minerals, right? So the minerals, actually these are the compounds of minerals which occurs in earth's crust and are obtained by mining or called as minerals. Okay, so these metals will be in the form of minerals. Will be in the form of compounds, and we can that will be occurring in the earth's crust as compounds, and we can obtain it by mining. Okay, so example for those minerals are gold, silver, platinum, helium, neon, etc. Okay, then what do you mean by ores? See, those are the minerals that contain high percentage of metals from which the metal can be extracted profitably or called ores. Okay, so that's some difference between the minerals as well as ores, is it not? So most of the minerals, right? See, most of the minerals, the metals are present in small amount. Okay, and some minerals have little high percentage of metal. So, for example, iron, right? So when you take iron, that is, so when you take iron, this iron is present in 800 minerals actually. But among these minerals, like hematite, right? Hematite. So hematite is a mineral of iron, and also magnetite. Okay, magnetite. So magnetite. So hematite and magnetite, these will be containing some little more percentage, this a little high percentage of iron. Okay, so these two will be having little high percentage of iron. So these two minerals are used for the extraction of. Hope you might have understood the difference between the minerals and the ores now. See, in minerals it will be having very little quantity of the metals, whereas in ores the minerals, those minerals will be containing high percentage of metals from which the metal can be extracted profitably. Okay, so those type of minerals are called as ores. So hence all the ores are minerals, but all minerals are not ores. Okay, for example, when you take bauxite and china clay, so both are the ores of aluminium. Okay, both are the minerals of aluminium, but aluminium is extracted profitably from bauxite. Okay, so we can get the aluminium from a bauxite by profitably from a bauxite. Okay, we can get it from bauxite, whereas from in china clay it is not possible to get profitably. Okay, hence the mineral bauxite is an ore of aluminium, whereas china clay is not the ore of aluminium. Understood? Now you know the difference between the ores and minerals. Okay, students. So next we are moving on to the metallurgy. So next, actually it is the core topic of today. Is it not? The process of extraction of a metal in the free state from its ore is called as metallurgy. So what do you mean by metallurgy? It is a process of extraction of metal in free state from its ore. Okay, is called as metallurgy. So actually for undergoing this extraction, so there is some criteria or some important factors should be taken into account for the selection of ores, okay, from which we are going to obtain the metal profitably. So what are the criteria that has to be taken into account while selecting the ores are the availability of the ore. We should check whether this ore is present in that particular area in a little more quantity, okay. So the availability of ore should be checked. Next, richness of the metal content. So we should check whether the ore is having high percentage of that particular metal which is to be extracted. Okay. And the next thing which we want to find it out is the simplicity of the method of production. See what there are different types of methods through which we can extract metals from the ores. Okay. So we should check whether the methodology which we are going to follow is little simple. Okay. So these three are the important criteria for the selection of ores: availability of ore, richness of metal content, and simplicity of the method in the method of production. Understood? So the next important one is the steps involved in metallurgy. What are the steps involved in metallurgy? Okay, the first step is the concentration of the ore. So the ore should be concentrated, right? So the first step is the concentration of the ore. Next one is the extraction or isolation of crude metal. Okay, so extraction or isolation of crude metal from its concentrated ore. The first step is concentration of the ore. The second step is extraction or isolation of crude metal from its concentrated ore. And the last step is the refining of crude metal. So its other name is purification. So next to the crude metal will be extracted and the last step is the refining of the crude metal. So these are the different steps involved in metallurgy. Okay. So the first one, the today's topic is the core topic is concentration of the ore, because in concentration of the ore itself we are having various methodologies. Okay. So it's fine to see the concentration of ores alone in this session. Okay, what do you mean by concentration of ores? Okay, see the actually the ores are association. Now, why we are under why this step concentration of ores is undertaken in metallurgy as a first step. This is because the ores are normally associated with non-metallic impurities. Understood? Then rocky materials, then siliceous materials, okay, which are collectively called as a gangue or matrix, okay. So they are collectively called as gangue, okay, Gangue or matrix, okay. So what are matrix or gangue? Okay, gang. See the rocky materials or the non-metallic impurities or siliceous matters are collectively called as gangue materials or the matrix. Okay, so the process of removing as many as impurities or the gangue or the matrix to make the ore rich in the metal content is called as the concentration of ores. Okay, so what do you mean by concentration of ores? It's the process of removing the impurities or the matrix that are present in the ore so that the ore can be made rich in metal content. Okay, so this process is called as concentration of ores. Understood, students? So next is the next what we are going to see is the types of concentration of ores. So actually, what are the different types? The hydraulic washing or gravity separation. This is also having another name, that is levitation. Okay, hydraulic washing or gravity separation is otherwise called as levitation. And the next is methodology is magnetic separation. The next one is froth flotation, and the last one is leaching. Okay, so these are the different techniques we are taking into consideration while we are doing this concentration of force. Okay. So first let us see the hydraulic separation or the gravity separation or levitation. So before concentration of the ore, the ore in the form of lumps are first broken into small pieces in the jaw crushers. Okay. So the ores will be when we are taking it from the earth's crust, it will be in the form of lumps. Okay, very big pieces. So that should be first broken into small pieces in the jaw crushers, and then it should be powdered with the help of a ball mill or stamp mill. This is called as pulverization. Okay. So before concentrating the ore should be powdered well. First, it should be crushed into small pieces using jar crushers, and then using ball mill or stamp mill, it should be powdered. So this process is called as pulverization. Okay, that has to be undergone before concentration of the ore. Understood? So the first methodology is the hydraulic separation or gravity separation or levitation, right? So actually what happens in this methodology is, in this method, the ore having high specific gravity, okay, high specific gravity is separated from the gangue that has low specific gravity by simply washing with running water. So what do you mean by high specific gravity or low specific gravity? Actually in this method, when the ore particles actually, so high specific gravity means the ore particles which are heavier, okay. The heavier ore particles can be separated from the impurities which is having a low weight by simply washing with running water. Okay. So actually the oxide ores like hematite. Hematite, what is the composition of hematite? Fe2O3. Okay. And then tin stone is an O2. Okay. Okay, is an O2. So are concentrated by this method. Okay. So these two ores can be concentrated by this hydraulic separation or gravity separation or levitation. Okay. So what happens actually in this process is, in this method, the powdered ore is washed with a stream of running water. So that what happens? The lighter particles, what are the lighter particles? The impurities or the gangue. Okay. So they are the low specific gravity particles or the lighter particles. So these lighter particles will be getting washed away leaving behind the heavy ore particles. Okay, so leaving behind the heavy ore particles, the lighter impurities will be washed away by the running water. Okay, so this process is called as leviation. Okay, this process is otherwise called as leviation. Understood, students? So the next important method is magnetic separation. Okay, what is magnetic separation? Actually, this method is used for separating the magnetic ore from non-magnetic impurities. Okay, the previous method was used to separate the heavier ore particle from the lighter impurities. Whereas here, this method is used for separating the magnetic ore from non-magnetic impurities. Okay, example: SnO2 is separated from wolframite impurities, which is magnetic. So these wolframite impurities are magnetic in nature. It contains some iron, tungsten, etc. Okay, whereas this SnO2 is separated from these wolframite impurities, which are magnetic in nature. Okay, similarly, chromite, pyrolusite, and these two minerals are having magnetic property and can be removed from non-magnetic siliceous impurities. Understood? So this particular method, that is magnetic separation, is specifically used for separating the magnetic ore from non-magnetic impurities. Understood, students? Next, we are going to see the methodology. See, this is the actually what happens is the powdered ore is dropped over a belt. Okay, this is a belt, right? This belt is moving around two rollers. This belt is moving around two rollers. One is magnetic and another one is non-magnetic. See, this one is magnetic, okay, and this is non-magnetic. Understood? So a belt is running over two rollers, which is this is magnetic and this is non-magnetic. Okay. Now this powdered ore is allowed to pass through this. This is poured or dropped over the belt, which is moving around the two rollers. The magnetic particles, okay, the magnetic ore particles get attracted by the magnetic roller. So when this powdered material is passing, the powdered ore is passing through this, the magnetic ore, okay, the magnetic particles will be getting attracted by this magnetic roller and this fall near to it. Okay, this will be falling near to this magnetic roller. Okay, whereas the rest of the impurities or the gangue particles will be flying off. Okay, it will be flying off from the heap away from the magnetic roller. It will be flying off from the magnetic roller. Okay, away from the magnetic roller. So thus we can separate the non-magnetic particles from the magnetic particles. Understood, students? So the next very important technique is froth flotation process. Okay. So this method is specifically used to concentrate a sulfide ores, specifically to concentrate sulfide ore, that is zinc sulfide, okay, PBS, okay. So these are the different types of sulfide ores. So in order to concentrate these sulfide ores, and also when the ore particles are lighter than the impurities. So the first methodology, that is hydraulic separation, we separated heavier ore particles from the lighter impurities, is it not? And in the second methodology, in the magnetic separation, we separated magnetic from non-magnetic impurities, is it not? Here, the lighter ore particles are separated from the impurities. Mean the impurities will be heavier here. So for those type of the ore particles, we make use of froth flotation process. Okay. In this method, the crushed ore is suspended in water. So this methodology has different steps. Okay, first it will be crushed and the powder ore will be crushed and it will be mixed with water and also will be mixed within the with the frothing agent like a pine oil or eucalyptus oil. Okay, so the ore will be first suspended in water and that will be mixed with the frothing agent like pine oil and eucalyptus oil. Okay, sodium ethyl xanthate is also added as collector to enhance non-wettability of mineral particles. Okay, so this mineral particles wettability should be non-wettability should be enhanced. For that, a small quantity of sodium ethyl xanthate is used as a collector. Okay, and the next and aniline, small amount of cresol and aniline are added as froth stabilizers. Okay, so these froth stabilizers are used to increase the binding force. Okay, binding force between the particles of the ore and the froth. Okay, so these are important things which has to be noted while learning this froth flotation process. Okay, and then some amount of depressants are also added. So what are the things added here? Frothing agent, okay, then collector, then froth stabilizers, and then depressants. What is the use of adding this depressants? Actually, sometimes it is possible to separate two sulfide ores by adjusting the proportion of oil to water or by using depressants. Okay. So for that purpose only we are using depressants. So the usage of this depressant I will be explaining after explaining this process. Okay. So what happens during this froth flotation process is, see, I have given two diagrams, right? So this diagram is little complicated. It is given in your book, but anyways, this is the skeletal. So let me explain with the skeletal diagram first. Okay. So this is the agitator, right? This is the agitator, and through which we will be passing the compressed air. Okay. So the mineral particles become, see, we are adding the mineral particles with water and the frothing agents like pine oil and eucalyptus oil, and also sodium ethyl xanthate, that is the collector, is also added, and the froth stabilizers like cresol and aniline is also added. So that will be taken here, that will be present here. So the water containing pine oil and the sulfide ore particles, everything will be here. So what happens is, when a compressed air is allowed to pass through this agitator will start to move. Okay. So the rotating pedal against the mixture and draws air in it. So as a result, the froth is formed. Because of this, froth is formed, that is bubbles, right? Froth is formed, which carries the mineral particles and moves to the surface. So the froth or the bubbles will be carrying the sulfide ore particles to the surface. Okay. Since the froth is lighter, it can be skimmed off. Since it is lighter, it can be skimmed off. This you can see here in this diagram. See here the agitator, this is the agitator, this is moving. Because of this, a froth will be formed. This froth will be taking up the sulfide ore to the surface. Okay. Since the sulfide ores are lighter, that will be skimmed off and we can collect through this. Okay. We can collect through this, right? Then after collecting this sulfide ores, it can be dried for recovery of the ore particles. Okay. And what happens to the gangue particles or the impurities, that will be settling down. Okay. So that are preferentially wetted by the water and settle down at the bottom. So the gangue particles will be settling down because it is wetted by water. So it will be settling down, whereas the sulfide ores will be taken up by the froth or the bubbles to the surface, and from the surface it will be skimmed off and it will be taken out and dried, and we can remove the sulfide. Understood here, students? So here, what is the role of the depressant? So actually, this depressant's role, actually, for example, let me explain with an example. For example, in the case of an ore containing this zinc sulfide and PBS, okay, if a ore is having two different substance sulfides, the depressant is used is NaCN, sodium cyanide. We'll be using sodium cyanide, okay. So the depressant used is sodium cyanide, right? So what happens is, this depressant, it selectively prevents the zinc sulfide, this sodium sulfide, it prevents the zinc sulfide. Preferentially, I mean, what to say, it suppresses or it prevents the zinc sulfide from forming the coming to the froth by forming a complex. What complex it will form? It will be forming like CNA2ZnCN 4 times. See here, this is an important question, that why we are adding depressant. This type of questions you can expect in NEET. Okay. So depressant, it selectively it prevents the zinc sulfide from coming to the froth by forming a complex. Okay. This forms a complex and allows only PBS to come with the froth. Okay. So when this ore is having both zinc sulfide and PBS, this depressant which we are adding sodium cyanide will be forming a complex with zinc sulfide, and it will not allow the zinc sulfide to move with the froth, but it will, the zinc sulfide will be settling at the bottom, right? Whereas the PBS will be moving up. Understood, students? So these are the points coming under froth flotation. So you should be thorough with the frothing agents, with the collector, froth stabilizers, okay, and the depressants. So the next important methodology is leaching process. What is by leaching? See, leaching is a chemical method of concentration of ores. Okay. In all the other techniques, we are using water washing and then magnetic rollers. Okay. And the previous one, we are using an agitator with the different types of substances. Whereas here, leaching is a chemical method of concentration of ore. Okay. In this method, the ore particles get dissolved in the solvent to form soluble salt or the complex, whereas the impurities or the gangue particles remains undissolved. Okay. So in leaching process, the impurities remains undissolved, whereas the ore particle will be mixing with the solvent, forming a soluble salt or complex which can be removed. Understood? So now the first method, okay, the first type under leaching process is alkali leaching. So in alkali leaching, what happens is we can remove aluminium profitably. Okay, in alkali, let me take aluminium as removal of aluminium. Okay. So the bauxite ore, see, bauxite ore is rich in aluminum. So it has high percentage of aluminum. So this bauxite ore is heated with concentrated sodium hydroxide solution between 470 to 520 Kelvin, that is 473 to 423 Kelvin, and 35 to 36 atmospheric pressure to form sodium meta-aluminate. So leaving behind the impurities iron oxide and titanium oxide. Okay. So leaving behind the impurities are iron oxide and titanium oxide, this sodium hydroxide combines with the bauxite, aluminum of bauxite to form sodium meta-aluminate. Okay. So Al2O3 NaOH plus water, it gives two, yes, NaAlOH 4 times sodium meta-aluminate. Okay. So now what happens is this hot solution, right? This will be in the form of hot solution because the temperature we are maintaining is at 470 to 520 Kelvin, is it not? So this hot solution is decanted and cooled and diluted. So now this solution is neutralized by passing carbon dioxide gas to give Al2O3 3H2O. So the sodium meta-aluminate is then neutralized by passing carbon dioxide, and so that when you are neutralizing it forms Al2O3, Al2O3 3H2O, okay, plus sodium bicarbonate, okay, NaHCO3, sodium bicarbonate, okay. Now what happens? Now this precipitate is filtered off. This precipitate is filtered and it is heated around 1670 Kelvin to get pure alumina. So when Al2O3 3H2O is heated, okay, to 1000. So when it is heated to 1670 Kelvin, this gives a pure alumina Al2O3, okay, plus 3H2O. Understood, students? So this is what happening. So here we are getting pure alumina from the bauxite ore. So the next method is cyanide leaching. Here the crushed ore of gold is leached with aerated dilute solution of sodium cyanide. Okay, here we are making use of sodium cyanide, and here gold ore is taken. It is crushed, okay, and it is leached with aerated dilute solution of sodium cyanide. So the gold is converted into a soluble complex, and the gangue the impurities aluminosilicate remains insoluble. Okay. Now here this four. This is gold and this is the cyanide of sodium cyanide in the presence of oxygen and water molecule. We are getting a soluble complex. Okay. So AU. So we are getting a soluble complex, okay? It's a soluble complex of gold. And now what happens is this gold can be recovered by reacting the deoxygenated leached solution with zinc, okay? So this should be treated with zinc. In this process, the gold is reduced to its elemental state and the process is called as cementation. Okay, that process is called as cementation. What is cementation? This complex, soluble complex is treated with zinc. So during this process, gold is reduced to its elemental state. So what happens during this process is this AuCN twice will be treated with zinc, okay, so that it forms a complex Zn Cn 4 times 2 minus plus 2A. So elemental gold is obtained, okay. Elemental gold is obtained, okay, by this cyanide leaching process. Okay, the next method is acid leaching. Here the leaching of sulfide ores like zinc sulfide, lead sulfide can be done by treating them with hot aqueous sulfuric acid, okay. So now the zinc sulfide or PBS is treated with sulfuric acid, okay, hot sulfuric acid in the presence of oxygen. So this will be getting converted to zinc sulfate, ZnSO4, okay. So the sulfate is getting converted to sulfate and elemental sulfur plus water molecule, okay. So what's happening here? See, in this process the insoluble sulfide is converted to soluble sulfate and we are getting elemental sulfur also. Understood? The last process is the ammonia leaching. See here, when a crushed ore containing nickel, copper, cobalt is treated with aqueous ammonia. So here we are making use of aqueous ammonia. Okay, here we are making use of aqueous ammonia. So when it is treated under suitable pressure, this ammonia, aqueous ammonia, selectively leaches these metals. What are the metals? Nickel, copper, and cobalt by forming their soluble complexes like NaNH3 6 times 2 plus, CuNH3 4 times 2 plus, CONH3 5 times H2O 3 plus respectively. So from the ore leaving behind the gangue, okay. So this what happens is this aqueous ammonia, it forms a complex with the nickel, copper and cobalt of the ore, and it forms complexes. Okay, it will be in the form of a soluble complex. And what happens to the other impurities? So that will be leaving behind the impurities as insoluble complexes like iron 3 oxides or hydroxides and aluminum silicate. Understood, students? So this is what happening in ammonia leaching. Okay, well, fine, students, you might have understood the preliminary step of metallurgy, that is the concentration of ores and its types. We'll meet you with the next part of metallurgy, that is the extraction of crude metal and its types in a short period. Until then, it's Dr. Anita Raj signing off from you. Thanks.